you.
Hello, hello. Can everyone hear me? Oh, hello. Is the mic working? Perfect. Hello, everybody. We'll start in a few minutes. Looks like some people are still trickling in, so. Looks like this might be about everyone that we have, so we'll get started. Today we're going to be talking about IoT devices and smart home devices. Sorry, the mic's a little sensitive. We'll have a few different topics to talk about. We'll talk about how you can set up your smart home and some considerations you might make, such as networking stuff. They can be a little finicky, and where do you want your data to be stored? Privacy is a pretty big concern when you're talking about smart home stuff. And then we'll also take a look at the API that we're hosting for the challenge today. And we'll do a demo of working with the API and also talk about Home Assistant and show a little bit off there. And then we'll talk a little bit more about some potential automations you might want to do, and then do a wrap up. So thank you all for coming. Without further ado, we can get started. So when talking about smart homes, you might have heard of some devices that already exist, like an Amazon Alexa, Google Home / Nest. They're called Nest now. And Apple HomeKit are some common options. And then there are some other ways that you can control your devices, like if this then that, IFTTT, or Home Assistant, which we'll be talking about a little bit later today. These are all different ways for you to kind of get started with your smart home journey, so to say. And we'll be going into those a little bit further. So one major component when you're talking about IoT is deciding what kind of devices you want. What kind of things are you looking to do in your home? Usually you have at least some kind of assistant, so like a speaker, your Amazon Alexa, your Google Home, that kind of stuff. Maybe you even use a streaming stick, Roku, Fire Stick, those types of things to get your different various contents, Netflix and whatnot. And then you can usually control these with those apps and other digital assistants as well. Maybe you will use some light bulbs. I use a few in my home. They're great. Automated timers and whatnot, really useful. Smart plugs, which can do various things, more than just turn on and off. You can measure all sorts of data with them, like how much power is my laptop using, or my fridge, that kind of stuff. You can control your climate, so like your HVAC system. Maybe you want to be particular about the climate control in one specific room. You can use some stuff to control your thermostat with that. Other various sensors that we'll talk about some of, even for security systems, you also have included in this, and then some robot vacuums and stuff. So we'll talk about what considerations you might want to make along this journey and how you might do that. So you start by planning your installation, of course, and where we just talked about, you want to line on your goals first. What are you looking to do in your home? What things do you want your home to do for you automatically? And deciding what you might want to automate or see is a good way to start there. Another major consideration, and Elaine is coming in. Oh, okay. Another major consideration is what kind of ecosystem you want to lock yourself into. A lot of those ecosystems, like Google and Amazon Alexa, kind of have their own bundle of stuff where you can use everything exclusively in those ecosystems, and they don't play nicely with others necessarily. Or there's some more open source standards that you might consider as well, which we'll talk about a little bit later, such as Thread or Zigbee and Z-Wave, which also have their own kinds of lock-in. Another thing is security. Security is a major consideration as well. Some of these things connect outside to the cloud. Sometimes they just broadcast data aimlessly. There's no encryption, all sorts of stuff where you might not want your secret data exposed publicly. With the various different options too, it of course costs different amounts of money. Something like Amazon usually costs very little money because they don't actually get you on the devices. They charge you for using other Amazon stuff. So there's different trade-offs for low budgets versus high budgets, and the different technologies that we'll be talking about make a lot of choices for you when it comes to budgets. And also how you want to power these devices. Do you want them to be plugged into a wall? Do you want them to be battery powered like this? Do you want it to be powered over Ethernet, for example, if you want to put your networking and your smart power all in one? So we'll talk about those a little bit later as well. But let's talk about networking a little bit. So with home networks, it's kind of anything goes. You kind of get to decide how you want to integrate your smart home with everything else you have, such as you can plug it in via Ethernet, like I mentioned before. A very common one is to buy something that connects to your Wi-Fi and then talks to the cloud to be able to control that. Even Bluetooth. Bluetooth is a very common starting step at the very least for smart devices. And then there's also some like fully integrated ecosystems like Philips Hue, for example, that you might have heard of. These are usually hub-based ecosystems where there's some kind of central controller, and then all the other devices through some means talk to that central controller, and that kind of dictates how you might connect to it. When you're talking about enterprise networks, such as UC Secure, when you're in a dorm or maybe your apartment has a centralized Wi-Fi system that they use, it's a lot harder to have smart devices because they control what can connect to the network. So when I went to UC, there was some challenges connecting different devices, like my Alexa, for example. I had an Alexa in my dorm room, and it was very difficult to get that working. I think I had to connect to the BYOD network, if that still exists, and I had to do something with registering a MAC address, I believe. It was a great time. So we'll kind of talk about a little bit how you might be able to handle that instead, and some ways that you can get around using Wi-Fi in that case. It also lets you have stuff like your own hub. Raspberry Pis, very cheap, all things considered. I think you can still get them for like 20 or 25 bucks at like Micro Center or online. And there's a various assortment of open source software you can host and different devices you can connect. Like this one I have right here. It's a little hard to see. We'll use it later today. I'll hold it up. This one's for Zigbee. It lets you turn basically any computer, Raspberry Pi, my laptop, some server you might have in your home, into something that can talk to the various different things, like Zigbee I mentioned, which avoids the network entirely. Other things like Bluetooth, for example, connected to your phone, very easy to set up usually. Most things at this point already speak Bluetooth, so you'd be able to use something like that for some more entry-level devices that you have, although the selection can be a little limited. So we'll see that later today. We're at UC right now, obviously, so you'll be able to see that we can run all of these smart home things I have on this table without having to touch Wi-Fi at all. One other consideration that we had talked about was privacy and data sovereignty. Data sovereignty being, where is your data located? Is it something that you control? Is it something that someone else controls? Does it exist on your device? Does it exist in AWS? These are all kind of considerations for how you want to control your situation. For example, if you're hosting it on your device, you host something like a Raspberry Pi, or you buy a pre-built hub, such as like the Philips Hue, and you will be able to connect to everything on there, and all the data stays on that device or where you specify. So you might be able to have a NAS server, for example, running on your it's all the way up. Is that a little better? Maybe, maybe not. Hello? Sorry about that. Hello? Is that working pretty well? Okay, good enough. I'll talk a little louder. Yeah, sorry. So, data, if you're storing it on your device, you could just say where it is. Maybe you have a NAS server running. I have one at home that I like to use where you can kind of store various different things. The data that comes from your IoT devices, maybe some Linux ISOs that you downloaded to stream when you're not wanting to pay for Netflix or Amazon or any of the other various different streaming services. And or just if you don't want to use cloud storage, if you don't want to use Google Drive, OneDrive, you can all do that on a NAS as well. And there's awesome integrations that you can also have for kind of controlling your data in your rest of your smart ecosystem too. And of course, the other option is the data is stored somewhere else on someone else's device. When I first started buying IoT stuff, I bought some Govee, I believe, Govee stuff, which you plugged in, connected to your Wi-Fi, and then all of the data got stored into Govee's cloud. And then from there, you'd be able to use that. But of course, that means that all the stuff that you do with it has to go through their cloud. And there's various different constraints when you're working with this, such as your Wi-Fi goes out, and then all of a sudden you can't turn on your light bulb. And that's always a fun thing. And there's sometimes ways around it, but if you have your own ecosystem at home, it's also a good way of getting around that as well, where it doesn't have to connect to the internet. So it also doesn't let you have to rely on other people for hosting those services as well. If Govee ever went out of business, all of a sudden my light bulb doesn't work anymore. Something else to consider. And then even if you do have these devices that don't necessarily need the Wi-Fi to work, oftentimes they will still try to send some kind of telemetry up to some kind of home network, not home network, some kind of enterprise network saying, hey, I want to see if people are using this product, how are they using my product, so on and so forth. So there's tools that exist like Pi-hole, for example, which you can run on a Raspberry Pi. And it does a great job of kind of scanning all the traffic that you're sending out and blocking different things. This also works for ad blocking, if you've heard of that. Instead of having to install a browser extension, something like Pi-hole will also allow you to block those ads and other various things as well. So telemetry control is something that you might want to consider as well when setting up smart home. And we'll talk a little bit more about the KV challenge, which is based on smart homes. We have a cloud-like service setup that I'll go to now. Perfect, it's loading. And yeah, so this would be kind of as if you're talking to a service like Govee, if you were, getting your data from that and trying to build automations around it. To get started with our ecosystem, you will be able to use this generate token command. If we go to test request here, we can specify the team name that we have right here. I'll do JWhiting test for the team name. This can be whatever your team actually is. And then we'll go ahead and send the request and get our token back. I'll copy this token real quick, and we can go explore some other parts of the API. When you're using someone else's service, the first place you usually go is to check out what exists on that service. And this has all sorts of great details for the various different types of data that you can get through our API. Not all services host something like this, but usually there's at least some kind of documentation for getting at your data. And to see what kind of data we can pull, or rather where we can pull the data from, list queries are very good for that. So we'll go ahead and add in our authorization header here, which will let us say that we can use this. If we did not have this, which I'll show now, it'll give you an unauthorized error. So if you see this error, it'd be good to add the authorization header like we have here, specify bearer, and then put your token in after it that we got from the other endpoint. And now if we send it, you'll see that there is various different sensor devices, as this endpoint would suggest, that we can check out, and the types of data that they also provide. So we have a generic test sensor here. We have a motion sensor, some lights, bed pressure, TVs, so on and so forth. So let's pick one. What does the dishwasher current look like? How much power is our dishwasher using? We can go over here and get some information about the sensor. Do a quick test request here where we specify the ID. Of course, we also need our authorization header. And let me get that out here. run that, we can see that right now our dishwasher is not actually reporting anything, so perhaps our dishwasher is off. We can go back and open this in another, not another tab. Let's duplicate this window. And maybe we try to find a different sensor that we can use as well. And when we're exploring this API, we can kind of get some ideas about how we might try to use it. Let's do the test sensors. I know that has data for sure on it right now. We go back here, get some details about it, put in a different ID instead, and there we go. We have a current test value of 61. And if we keep hitting it, at some point we should see it change. I would hope. But if we wanted to go see more data, we can take this and look at some samples that are being taken of it. So go ahead and put in the ID again and our authorization header. And if we go ahead and submit this, we'll be able to see a whole bunch of data points that it's recording. So the last one was the 61, a little bit different there. We're at 70. And I might start getting ideas about how I can visualize this. Maybe like a nice little graph would be really cool to see what the sensor is doing over time. There's also ways of aggregating the data. Maybe you want to look over a 5-second time interval, perhaps, or 5 hours. Maybe you only care about the large scale. And there's a way to do that as well. So tons of different ways you can consider using this API for your challenge. If you're looking for more details on that, it is in the live site on the in the resources section. And we have a couple links that we'll be able to see later on as well for that. And yeah, are there any questions that anyone might have about interacting with our API or about the challenge at this time? Yeah. Mm-hmm. Mm-hmm. That's a great question. So for everyone else, it was about Pi-hole and how loading up a site like YouTube, for example, might change some various different things like ads and how you might ignore, for example, ads on YouTube, or maybe you want to allow ads on YouTube or some other specific platform. By default, Pi-hole has a blacklist, per se, of all sorts of different common URLs, and that's how most of these ad blockers work. They usually have some kind of deny list of URLs. And if you want to specifically allow one, you'd be able to remove that from the list or add it, so on and so forth. And so by default, all those common ones like Netflix and YouTube are blocked. But in Pi-hole, there's a very nice graphical interface you can use for this. You go to the settings and you can say, change this list and say that you want to allow the ads from YouTube. You would just remove all the ones from YouTube or add it to a different list that says, yes, I want to allow these for this amount of time, for example. So that gives you like a more holistic view, if that makes sense. Cool. Any other questions anyone had? Anything so far? Cool. Awesome. Well, if there's no other questions about that, I'll jump into the Home Assistant demo that we have. So I have a quick screenshot here that we'll set up, but if I go to my terminal, I can start up Home Assistant. It's very easy to deploy. It's great. We'll have it loaded up here in a second. But their documentation for getting started is very simple. You can install it on any number of devices. They have different guides for your different types of devices. So if you're doing Raspberry Pi, they have a purpose-built Raspberry Pi installation guide where you just copy a few things and run them, and it sets it all up for you. It's really cool. And where I'm running it in Docker at the moment. And they also have a very easy guide for that. You copy in a configuration file and run one command, and you're theoretically off to the races. It's not very happy about something at the moment. I swear this worked like an hour ago. it's upset about not being shut down completely, I believe. Let's try to give it a restart real quick. And if not, we can see about doing a fresh install of Home Assistant, which would be great. There we go. Second time's the charm. So loading some stuff up here. And as I mentioned earlier, we have this fun little USB device I have right here that lets us talk to Zigbee networks, which allows us to get around all of the Wi-Fi considerations that we have. And you can see right here, this is that so-called USB device. And we'll try to add a few different devices now. I have tested this before, but you never know. Maybe these things won't work. So the first thing I'll try to do is this button here. This will allow us to do different basic automations later that we'll see and be able to set up in Home Assistant as well. And if I go to add device, add a Zigbee device, we'll see that it should be searching, and it's starting right now. I have this called B1, just for button 1, and let's say that I want to use this in the bedroom. There's also a nice temperature sensor and humidity sensor I have to show off today, so maybe this is being used for climate control. Let's see, where's the, there it is. Or maybe you can use something like this for your, if you have a greenhouse, you can do some stuff with plants and whatnot. In just a moment, we should see that connect as well. There it goes. Look how easy this is. So great. And then I'll turn this on. We have a couple different things. I'm sorry for the blinding light. We'll be able to see that pop up here in a second and control it. There's two devices here. We have a smart plug and a light bulb, and they both have appeared here. So we have our button, our temperature humidity sensor, our light bulb, and also our plug, all with various different names. So now if we go back, we should be able to see that they all exist here now. And I will go in and quickly turn off our light bulb so not everyone's blinded. Awesome. So with this, we can see that Home Assistant does some really awesome stuff for us off the bat. You can see that the overview page rather, is set up for us right now, and that we have all the different controls. So I can turn that light bulb on and off, or even I can go in and change how bright it is. So I can turn it down to a less offensive dull light, or change the color, which is also a cool thing that you can usually do with these things. With something like a plug, we often would be able to do some basic on and off automations for something that's necessarily not smart. Like if you have a regular lamp, for example, maybe you plug in a plug for that, and then you can plug your lamp into that plug, and now you can turn something that's dumb into something that's smart, per se. There's also some other advantages that this gives us, like it would let us see how much power it's using. So we can see right now, 1819 has about 122 volts going over their AC lines, and I'm not drawing any power from it at the moment, but if I plugged something into it, such as this light bulb, and assuming I turn it on as well, which we can turn on there, now we can see that in just a moment these sensors should update, and we're using about 0.8 watts, which is very little. It's an LED, so it's very efficient. But we might use Home Assistant as well to give us some kind of custom overviews and data over time. So I mentioned being able to visualize it with graphs earlier, and Home Assistant has some built-in functionality for that too. So I built this out yesterday, and you can see that it can pull in external data as well. I don't have any weather data per se being driven here, but it's talking to an external API to pull in some stuff for the weather, so we can see the forecast right now. We can also do our various different controls, like controlling our plug or our light, setting some stuff about our light like we saw before, changing that brightness to different levels. And we can also see how much this plug is used over time. So right now it's using very little. We can see that there's a nice short tail there, and the temperature and humidity sensor hasn't caught up yet, I wouldn't think. But in about 5 minutes, this should have some kind of more realistic data to show here. What I also like about this is it lets you see for these battery-powered devices how much battery is left in these AAAs I think it's using. So you can kind of keep track of that and write automations based on that as well. Speaking of, why don't we try to make an automation? Home Assistant makes it pretty easy. They have a very nice graphical interface for this, and it's in the settings under automations, and we can go and create a very basic one right now. So as I mentioned, we have a smart button right here that just lets us control whatever we want. And I'll add that as a device. I called it B1, so we use B1. And we have a couple different options here, if it's easy to see. I'm going to do it when I press the button one time, but there's also usually other built-in things for this too. And when I do that, maybe I want to turn my light bulb on and off, let's say. So I can do that as well. Select the light bulb there. If I wanted, I could say it turns on with a specific color too. But we'll leave it at whatever color it is currently at, and go ahead and press save. And we'll call this button light for now. So theoretically, if everything worked right, I should be able to press this button, and it turns off. Ooh, so great, so great. Of course, this isn't the most practical example per se. I wouldn't always want to do this, but maybe you do. You can have different buttons hooked up. You can even have smart light switches, let's say. And so you walk into a room, you turn it on with the light switch, then you go lay down in bed. How do you turn off the light once you're already in bed? Well, you might have a home assistant that you can help with that, or maybe you have a button on your nightstand. You just press the button and now your lights turn off. You might have heard like the old school clappers. They sell those too. You can buy smart clappers, but in the 21st century, I think you'd probably just want to use one of these instead. So those are some examples of what you might do with this. And Home Assistant is a very nice open source software that does not just integrate well with Zigbee, but also they have different integrations with other tools as well. So oftentimes Wi-Fi devices, Z-Wave, the other kinds of protocols that we talked about earlier can also be set up in here and added via this one common dashboard here. So they have all these different integrations with the different tools, even some more proprietary ones as well. And yeah, if you have some smart home stuff already, I might try out Home Assistant. Like I said, very easy to install, and just kind of start exploring everything and seeing if you can do something in it. It's very cool. Awesome. Any questions about what we talked about, Home Assistant, anything like that? Yeah. No, no. Connected Vision, to be clear, had nothing involved with Home Assistant, although we do use it. We do use it at Kinetic Vision for some stuff. So, for example, you might be a client of ours per se, and be really interested in how some of your customers are using your various different devices. That's something that is a common use case. The telemetry data that we talked about before that we wanted to block, well, some people like to join studies, for example, that let you try out a product and see how you're using it. So we use Home Assistant for stuff like that, where our client's able to do the various different device controls inside of one common dashboard that they can use as well. But Home Assistant in general is an open source project that has existed for quite a while now, homeassistant.io, and there's all a huge community around it that's been going for a very long time. And as you saw, the setup has only gotten really easy. They have a nice app that you can use to connect to your Home Assistant instance. You saw I was using it in the browser, but it doesn't have to be in the browser. So yeah, they have all sorts of stuff built around it at this point. You can go and explore it without even downloading it per se. But yeah, they have all sorts of stuff to check out. So when I installed it the other day, I went to the Linux section and went to the container where Docker compiles specifically, and all you have to do is, assuming you have Docker installed, put this file on your machine and then run this one command, and you're off to the races. That's all I had to do to install Home Assistant. As you saw earlier as well, installing devices got really easy. One single button press, and I was able to scan all 4 of my devices. It worked out really well. So, cool. Yeah. Yeah, great question. So for the recording, the question was about Home Assistant and the power that's visible here, and we were able to see that the power spiked up. There's some data in here from last night, but we also have various different data points from today. And the reason we saw that was there was nothing plugged into this plug originally. I originally had it plugged over here instead. And so to show the power get used, I plugged it into this one, which then triggered it to show the increase in voltage. Now that I've unplugged it again and plugged it into a different outlet, you can see that it's back at 0. So usually for these things, you have to have it plugged into the specific outlet, not just somewhere else in your home. But there are some really cool fancy devices I've seen, much more expensive than these were, where it'll be able to analyze different patterns on your power lines, essentially, like how are different things being used. Like it can kind of tell when you turn your refrigerator on or when your dryer is running, that kind of stuff, because those have very specific like inconsistencies that it pulls from the power lines, and it's able to detect that using some kind of algorithms and stuff. It's pretty cool. Very expensive, but for like a whole home solution, those do exist and can integrate with something like Home Assistant. So cool. Yeah. Other questions? Cool. Well, without further ado, let's talk about some other things that you could automate. So we mentioned a very primitive example here with just a simple button press and turns the lights on and off, but there might be some more practical examples that you can use as well. So let's say you want to wake up at 7 o'clock and you have some wake up routine that at 7 o'clock it turns on your alarm and increases the temperature in your home. Maybe you set it down lower at night to save on money while it's you're sleeping and are under blankets, and then in the morning you want to raise it to a more comfortable temperature to kind of get up and do stuff and turn on some lights automatically too. I have a similar routine at home for this, and it's very useful, just every single day. Maybe you also drink coffee and you hate having to set your coffee at night. As long as you put the grounds and stuff in or have a fancy coffee maker, it can also do stuff like turn on your coffee and let it be ready for you in the morning at a specific time. Same for going to bed as well. I use this one more often, in fact. It can do stuff like lock your doors if you have smart locks, or turn off your lights so you make sure that you're not leaving any lights on at night, and also decreasing the temperature, kind of the opposite as before. Or maybe you leave lights on at home and also don't want to be cooling your house when you're away. Let's say you go to work in the morning, and as soon as you leave, you're home smart enough to say, I've raised the temperature for when you were around. I know you're not home anymore and no one else is home. Let me decrease that temperature again. Make sure the doors are locked, that kind of stuff. Maybe if your doors aren't locked, I lock them automatically. Or maybe it does something like send you a notification where it says, hey, you forgot to lock your door. Any number of things you can do where the power is in your hands per se. Another common one is when you're arriving home, the exact opposite of that. Maybe you want the temperature to go back up or down. And another solution that you might use is watering your plants. Maybe you're really bad about watering your plants, but really like the idea of having plants in your home. And so that would usually lead to dead plants and so on and so forth. And this would potentially help you avoid that by having some nice moisture sensors that when the soil's too dry, it'll automatically turn on a little water hose perhaps for you and water your plants automatically. So there's a lot of different things you can do with automations as well. And what we're hoping from the KV challenge is that you would take the data that we have and build something cool around this. So we have a bunch of like mock data, and maybe you do some visualizations, maybe you do something where you have some automatic triggers, you look at the data and say, oh, this event has happened. What are some cool things I might be able to do based on this one specific data point I have? Speaking of, if you want, you can explore our challenge if you haven't already. The link on the left there goes to the full description. It's like a 2-page thing with all sorts of different specifics of our system, so like how you might use the system, some things you might want to do with it, and also how we will be judging the submissions at the very end. And then I highlighted it earlier, but we have the API for our system also documented. The link on the right there will take you to that documentation page, and you can check that out as well. To talk about some of the prizes, we have a few different things to give away. We have some smart light bulbs, some humidity and temperature sensors, not too dissimilar from that one, and then also some Raspberry Pi Zero kits, excuse me. And I think we have 4 of each of these. So if you have a larger team, you can have it, or you can have them all at the end too if you're just a solo party. Really get started on your smart home stuff. Any questions about the challenge or prizes or anything? Cool. Finally, for all of those who are interested, we are having the Klube participation thing here. So if you've downloaded the Klube app, scan that now and you'll get the credit for it. And otherwise, this is the end of the presentation. So thank you all for attending and for all the questions. If you have any other questions about anything we talked about today or about the KV challenge, please come find me, or in the back there we have Scott and Tyler as well. They'll be more than happy to help you out with any of this. So awesome. Oh, yes. Various amounts of time. I'll be here until this evening, probably about 7 or 8 o'clock, and I'll be back in the morning. I'm not sure what the other two gentlemen in the back are planning, but they'll also be around for various different times. And of course, message us on Discord if you have any other questions. I'll be looking at that even after I leave today. So, yeah, cool. Well, thank you all. That was this device. Yes. Okay. And this is specifically because I wanted something that